The last thing we need to look at in quantitative microeconomics is how you can figure equilibrium after a change to demand and supply. That is, looking at the price mechanism mathematically. I'm assuming you already know how to do this. If not, you need to stop this video and go back a couple videos so you can see how to establish equilibrium in the first place. Let's remember, first of all, that when we're talking about a change to the demand curve, when a demand curve is going to shift right or left, or when a supply curve is going to shift right or left, what we really mean is that an underlying change, or a change to an underlying determinant of demand or supply, is going to be the result. So for example, typically for demand, we talk about a change in taste, although of course there are others. And for supply, we talk about a change to the price of a raw material. Let's use as an example a change of plus or minus 50 at any and every price. So if there's a change of positive 50 at every price, because maybe people just have a greater taste for the product, maybe there's a new flavor, or there's an added nutritional value or something like that, what we're going to expect is that the demand curve is going to shift to the right here. Well, since we're saying it's plus 50 at any and every price, we can see that real quickly by doing up a little schedule. Our old A-intercept was down here at 0 and 400, so on our original curve, we have, when price is 0, we have a price of 400. Well, now that's going to be 50 more. That's not difficult. So now it's going to be 450. What that means is this point here that is 400, the new A variable is going to be 50 over to the right, so a little bit off of what I can draw here. On the other hand, if it decreases by 50, so if people figure out that there's an ingredient that is harmful, or maybe a competitor lowers their prices so that there's less demand for this product at all prices. Anyhow, now again, we're going to go from 450 to the left. So that's going to be 350. Well, that's pretty simple. So if we were going to graph this second curve, this point is the new A variable, and it's 350. To show that into a diagram, or to put that, out of the diagram, but then into a formula itself, we just go right down here. And we take that information of adding 50, or subtracting 50, and we just write it into the formula. So our old formula was 400 minus 8p, and then we add 50 in the top example, and subtract 50 in the bottom example, then we simplify. So this, of course, 50 can't be added to 8p, but it can be added to 400, so this becomes 450 minus 8p. Our second example becomes 350 minus 8p. Notice in both examples that the coefficient of p, that is 8, remains unchanged. Nothing at all happens to it. When we graph this entire curve is going to shift by this amount. This amount I'm defining as 50, so that means this is also going to shift over this much. And this is going to shift over this much. And we should get a new curve that is perfectly parallel to our original curve, and we call it D2. If we are showing a change of plus 50, then it would have moved to the right, again by 50 units at every price. I can go in and test that, but again, that's probably more appropriate for an older video or an older concept. For supply, it's going to work out the exact same. If we take the C variable, here you can't quite see it, but we know that it's negative 100, which is a bit of an odd concept. If I shift supply to the right, again, if I increase supply by 100 at all levels, that's shifting it to the right. Think about the Q axis. So if I shift it to the right, well, on S2, this would become, well, if it's at minus 100 over here somewhere, it's going to shift over by 100 and now be at 0. Whenever we have that, whenever we have a C variable of 0, what that means is it starts right there at the origin. And again, it's going to be a parallel line, so it's just going to go over there, and we're going to show a shift to the right. And that shift to the right, it would be by a factor or by an amount of what we defined, which is 100. If it went to the left, I would show it somewhere else, maybe here at 25 and 200, that's on my original curve. If it shifted to the left, this would now be at 25, it would be 100. So instead of 25 and 200, it's 25 and 100. And that would be our new curve through there. Again, we can put this into the formula just mathematically. So if I add 100, well, negative 100 plus 100 is going to become 0. So we typically won't write that out. So QS equals 0 plus 12p. We're just going to write it as 12p. Here, QS equals negative 200 plus 12p. So the concept is the same. It would be useful to go in and test this real quickly, so let's just do one example for each. Let's take this example here. So this was when we shifted to the left, so we're talking about this point here. So here's our formula. QS equals negative 200 plus 12p. Well, price was 25. 12 times 25 is 300, so negative 200 plus 300 is equal to the 100 that we found. Over here, we can take an example. I guess we really only have, well, let's use this one here. So we rewrote this formula as this. So quantity demanded equals 450 minus 8p. So when the price was 0, 8 times 0 is 0, 450 minus 0 is, well, 450. That's simple. Once we know how to shift our curves appropriately left and right, then it becomes an issue of taking that and putting it into a formula and then showing it on the diagram. So let's start here with an example of demand changing by positive 50. We're working with the same formula that we were working with before. So let's rewrite our formula. 450 minus 8p. So we know that the new A is going to, I'm sorry, I skipped a step. So we're going to take the positive 50, put it in here like we just did, and it's going to be 450 minus 8p. Well, we know the A variable is this, so our new A variable is 450. So on the diagram over here, I'm going to go to 450, and I'm going to make this the A variable. We had already, and again, I've already solved for equilibrium here. If you don't know how to do that, you need to go look at a different video. I've solved for equilibrium in the original, and it was 25 and 200. Well, we said that at 25, there's 50 more demanded, so the new quantity demanded at the old price is going to be 200 plus 50. Well, 250, that's pretty easy. So this is going to be about here. And that's going to be our demand curve through there, our new demand curve. So this is D2. That's not going to be our new equilibrium point though. That's the most important thing. You see that at the old price, we now have greater demand, 250, than there is supply, 200. So we're going to work towards a new equilibrium that will be at a higher price and somewhere in between those two values. So all we need to do is we need to remember what's changed, demand has. So we need to take the new demand formula and let it equal the new supply formula and solve for the result. So this is going to be 450 minus 8p is equal to, nothing's happened to supply, so we're going to use the old supply formula. Remember, we have to get the p's on one side and the no variables on the other side. So this is negative 20p is equal to negative 550. We'll solve. Sorry for my handwriting, it's kind of hard to write at this angle. Anyway, it's 55 over 2, so that's going to be 27.5. Okay, we would take this number and put it back into the formula and solve it that way for quantity as well. Okay, for supply, if it changes by minus 100, again, new C variable is going to be negative 200. That's not very useful though, because I can't actually show that on the graph. I can't show negative 100 or negative 200. But I can show the new quantity supplied at P star 1. So if it's going to shift by minus 100, it was 200, and now it's going to be 100 there. Okay, so that's one point of our supply curve. I don't know another point yet, so I can't draw the curve because I couldn't show minus 200. So I'm just going to solve for equilibrium next because I know that'll be a point as well. So we take again the new supply curve. And we let it equal the old demand curve because now in this example we haven't moved demand. Get all these digits on one side. I'm going to add AP to both sides. So this is going to be plus 8p, and then I'm going to add 200 to both sides. And this is going to be 20p is equal to 600. And that's going to be 30. Okay, so I know P equals 30 is going to be where my equilibrium is, which means it's going to be right there. But I don't know where that is, so I do need to take 30 and put it back into my new formula. So we're taking 30 and putting it in here. So we're saying QS equals negative 200 plus 12 times 30. 12 times 30 is 360, so P equals 160. Let's check it with the demand curve too. 400 minus 8 times 30. 8 times 30 is 240, and 400 minus 240 is 160. So I got the same thing both times. So that means this point right here, it may have looked like 150, but it's not. It's actually 160. And then this is going to be our new supply curve. I am the world's worst shot ever. That's all you need to be able to do. You need to, when you're presented with one of these changes, you need to know where to put the change. Notice in all of these, the coefficient of D or of B, so negative 8 here or 12 in this example, that coefficient never changed. We'll do that later. For now, these are straight shifts. The new line is always parallel to the old line. So I need to know where to put the change. So I put it here and I reduced it or simplified it to that, and then we're simply using that formula with the old formula and solving for a new equilibrium.